going to be talking about Module 12, which is electrochemistry, and more specifically, batteries. So, what is electrochemistry? Electrochemistry is the study of chemical processes that cause electrons to move back and forth, move between elements, and the movement of electrons from one element to another is known as a redox reaction. And to understand batteries, we're going to talk a bit more about redox reactions, what they are, and how they work. So, oxygen reduction reactions are redox reactions. And redox reactions are oxidation and reduction reactions that are happening simultaneously. So, two reactions that are both happening at once. And the two chemical species are transferring electrons back and forth. That's kind of how they're both happening at once. So, the one gaining electrons is the reduction reaction, and the one losing electrons is the oxidation reaction. So here we have an example. You can see how A is going to be giving its electrons to B. So A is losing electrons, the oxidizing agent. So as you can see here, they become positive because they lose an electron. And then B here is gaining electrons. So it is the reduction agent, and then it is going to become negative. And then an easy way to remember the saying is Leo the lion says grr. Leo, losing electrons, oxidation, and then grr, gaining electrons, reduction. And now that we understand oxidation reduction, we're going to talk a bit about batteries. So now that we understand it, reactions that are occurring in batteries are half reactions, kind of like I said, two reactions happening at once. So here's an example of what occurs in a simple alkaline battery that we use in our everyday lives. So here we have zinc reacting with manganese dioxide to produce manganese 2 oxide and zinc oxide. But to do this reaction, we are going to have to split it up into two half reactions like we just talked about. So in the first one, we have zinc being oxidized, loses an electron, and turns into a zinc 2 ion. Here you can see with the 2 plus charge. And then at the same time, manganese 4 is being reduced to manganese 3. So here are the two unbalanced half reactions that occur at the same time. And then once we balance the two half reactions, we see that 2 electrons are released during the oxidation of each zinc atom, and 1 electron is consumed by each manganese 4 atom. So, the half reactions in batteries need to be separated, like we just talked about. And this is done by the anodes and cathodes in batteries. Electrons pass from one half reaction to the other via conductors. So, just to explain half reactions a little bit more, here we have a simple galvanic cell. So right here we have the anode, and right here we have the cathode. And then in both of these little solution pools, it is its own half reaction. So the electrons are going up through the wire and causing a current up here. And then the electrons are going in between the two half reactions, between silver and copper, the anode and cathode. And then in here we have these solutions with this salt bridge. And the salt bridge does not move electrons. It maintains charge, balance, and preserves neutrality. So when there is too many negative charges, it's going to get some positive. When there's too many positive, some negatives are going to come over, and it maintains the charge balance between the two. But because these two half reactions are occurring, there's going to be a current in this wire, and then that is going to cause electricity and kind of how the battery works. So now that we understand batteries, we're going to dive into lithium-ion batteries specifically. So lithium-ion batteries are a type of rechargeable battery that are commonly used in portable objects such as cell phones, laptops, and MP3 players. So in lithium-ion batteries, the lithium ion moves between the positive and negative electrodes, which are the two different half reactions it's moving between. The positive electrode consists of lithium cobalt 3 oxide, and the negative electrode is made of highly crystallized graphite. So here in this diagram, you can see the graphite layers make the negative electrode, and the oxygen and metal make up the positive electrode. So this is how a charge cycle would work in a lithium-ion battery. So here we have the positive, the negative, and then kind of the little current in the middle. So in the charging cycle at the positive electrode, the lithium ions, represented with the green arrows, move between the positive and negative electrode, which is right here, to maintain its charge balance. And then one cobalt 3 ion is oxidized into cobalt 4. And then at the negative electrode, lithium ions enter between all of the graphite layers and are reduced into metal. And then when they're reduced, they head back over to the positive electrode, and then they will be oxidized and sent back to the negative electrode. So here's kind of a little diagram. You can visualize where everything is going and how that works. So hopefully that was helpful. So now we're going to talk about the advantages and disadvantages of lithium-ion batteries. So the first one is cell voltage. And cell voltage is the voltage produced by each lithium-ion cell. And it is around 3.6 volts, and this requires less cells in many battery applications. So this means only a single cell is needed for smartphones, and this simplifies power management. You're going to need a lot less cells, only the one, so it makes it a lot more simplified, more compact. The next one is the self-discharge rate. So lithium-ion cells have a much lower self-discharge rate, which means it stays charged for longer. So your smartphone, you charge it overnight, you wake up in the morning, you use it all day, and it takes forever for the battery to discharge. And then you've used it the entire day without having to charge it. And then the last one, number 3, high energy density. This means that lithium-ion cells can operate longer while consuming more power. So this is a bit similar to self-discharge rate. So we used a smartphone for self-discharge, being able to stay charged for longer. But then a good example for high energy density is an electric vehicle. You're going very far, you're driving very far, driving long distances, and a car is going to use a lot more power than a smartphone. So you're going to want a really high energy density so you can travel far without having to recharge your car. And now for disadvantages, the first one is the protection required. So lithium-ion batteries require protection from being overcharged or charged too far. They also need to have the current maintained within safe limits. So there's extra safety precautions and protection that needs to be done. It just makes it a lot less simple, less easy compared to other self-charge batteries. The second one is aging. So lithium-ion batteries suffer from aging, and they often can only withstand 500 to 1,000 charge cycles before its capacity fails. This means you would have to change the battery, replace it, which is going to be costly. It's just inconvenient. And then the last one is cost. Lithium-ion batteries are typically around 40% more expensive to manufacture than nickel-cadmium cells, which are another type of rechargeable battery. So we talked about the advantages and disadvantages, but now we're going to talk about if they are sustainable. So lithium-ion batteries, like we just said, are used in electric cars, and this is obviously very sustainable, good for the environment because this reduces the amount of carbon emissions. But despite its efficiency as a battery and what it can do, there are ongoing debates about its environmental friendliness. Because lithium is extracted through water mining, which requires enormous amounts of water, as well as the toxic chemicals needed to produce lithium. And this leads to water contamination. So there are cars out there reducing carbon emissions because they're electric. They're not taking any gas and emitting that into the environment. But to mine lithium, to use for these batteries, for these cars, so many toxic chemicals are being put out into the environment through the water mining. So they kind of cancel each other out, and it's kind of hard. You have to look from both sides to see which is kind of the side you want to choose. Are they sustainable? Are they not? Are they environmentally friendly? Are they not? So this concludes my presentation. I hope you enjoyed and you hopefully learned something about electrochemistry, batteries, or lithium ion cells. So here are my sources, and thank you for watching.